Here we go, one more time. Everybody's feeling fine. Here we go now. Yes, 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 here we go. Our math class has got their notes. You guys, maybe we could come up with a rap video. JK, that was pretty terrible, but now here we go. We're going to talk about two things in this, but we're really going to focus on the distributive property. But I do want to go over the identity properties to make sure that you've got that squared away. So our identity properties, remember, it's all about what can we do mathematically to a number and not change its identity. So what can you add or multiply to a number and not change what it is? Our multiplicative identity, remember multiplicative means we're going to multiply, is 1. Because we can multiply any number by 1 and it's not going to change, right? 23 times 1 is still 1. Negative 805 is times 1 is still negative 805. All right, our additive identity is 0 because hello, we can add 0 to any number and it's not going to change. 23 plus 0 is still 23. Negative 805 plus 0 is still negative 805. All right, so just a basic thing to go over. What we're going to focus on now, though, for the rest of this video is the distributive property. This is a big chunk of what we're going to spend today working on. The distributive property really just tells us that a multiplication fact can be broken up into smaller parts that may be easier to multiply. This is going to be incredibly important because when we are working with an equation or an inequality a little later, we have to apply this because we're going to have a missing number, right? It's going to be really how we're going to start solving these problems. So what we're going to do is actually share what's on the outside with what's on the inside. So let's pause and focus on just that. We have 5 parentheses, 9 plus 7, close parentheses. So we have to dig back in our brains and remember that a number next to parentheses means to multiply. So I'm going to add that little multiplication symbol in there. So that means we are sharing that 5 times with what's on the inside. 5 times 9. And then I'm going to keep whatever symbol is in the middle. And then I'm going to just keep sharing, right? 5 times 7. And so 5 times 9 is 45. Plus 5 times 7 is 35. And then we could add them. And we would end up with, what is that, 80? Here we go. Okay, now we're probably thinking, oh, I probably would have chosen just to add what's in the parentheses and then multiply, which is totally fine, right? Using the order of operations. But we could technically break it down into a smaller chunk, and breaking it down into a smaller chunk is what we're going to have to do when we have something missing, when we have a variable like we have here. So let's go ahead and focus on this next one. We have 10 next to parentheses. A number next to parentheses means to multiply. All right, so we're going to share that 10 times with what we have inside. Okay, now what's important here is that there's no number in front of our x that we can see anyway. There's actually an invisible number 1. So I'm just going to do that in like dotted lines to show that it's there. It's understood that it's there. We have to know that it's there, but it's not going to be written out. Algebra is all about writing things as simple as possible. So we've got 10 times 1x. We're going to keep whatever sign we have in the middle and then share with whatever is left. So 10 times 3. Okay, so what we would have here is 10 times 1, which is 10. So we have 10x plus 10 times 3, which is 30. And this is what we would work with as we're starting to solve our equations moving forward. All right, so let's take a peek at what this looks like. Because although this may look different, hello, if you have ever gone to Chick-fil-A or Burger King or Whataburger or Sonic and you have ordered value menu items like meals for your family, or for you and your friends, you actually have used the distributive property. We're going to see how with this next example. So distributive property using combo meals. So here's our example. If you would like to buy 2 of combo meal number 1, well, combo meal number 1, I'm going to get rid of this because it's kind of redundant. Combo meal number 1 includes 1 burger, so there's 1B, 2 French fries, so 2F, 1, actually, that's not a McCafe. What is that? Oh, I guess technically it is a McCafe, huh? But definitely doesn't remind me of coffee. So 1M. Technically, it is a McCafe. It says McCafe on it. So if we were going to get 2 orders of this, and then the cashier hands it to us through the window, how many burgers are we going to expect to have? Well, 2 burgers because we got 2 orders of it. We would expect 4 French fries because 1 order had 2 and we're getting 2 orders. And we would expect 2 McCafes, right? When you open your bag to check to make sure that you've received all of your items, you are literally applying the distributive property. Because what we did was take 2 times the 1 hamburger to get our 2 burgers. We took the 2 and multiplied it by the 2 French fries to get a total of 4 French fries. And then we took the 2 times the 1 McCafe to get a total of 2 McCafes. All right, so let's take a peek at what we're going to see down here for our next one. So if you would like to buy 3 of combo meal number 2, all right, I'm going to scratch this out and we're going to look at combo meal number 2. So we've got nuggets, Cokes, and French fries. So we're going to buy 3 of these. So we have 1 nugget, we have 2 Cokes, and 1 French fry. Okay, if we were going to open our bag after getting 3 orders of these, we would expect to have 3 orders of nuggets. We would expect to have 3 times 2, 6 Cokes, and then we would expect to have 3 French fries. All right, so again, you guys have worked with the distributive property without even realizing it. All right, so now we're going to do a few examples together. Okay, so remember, what we have here is multiplication, and we're sharing that multiplication with what's on the inside, right? We're sharing what's on the outside with what's on the inside. So we have 2 times 5, which gives us 10x. I'm going to keep whatever symbol we have, and once I move it over here, that's it. I'm done with it, right? I'm going to treat this 3 like there's no symbol in front of it. And then 2 times 3, which is 6. All right, every time I'm sharing that 2 times whatever is inside. And then that's it. We can't solve it. We can't do anything more because we don't know the value of x. Let's try our next one. Same thing. We're going to share what's on the outside with what's on the inside. On the outside, we have -2 times. So -2 times 10. Maybe you have to use Math Man. Remember, only multiplication and division. So -2 times 5 gives us -10x. We can't forget the variable. We're going to keep the symbol, and then we'll continue to share. So -2 times 3 gives us -6. All right, now we could keep it like this, but since we want to try to write things as simple as possible, the best way for us to write this would be like this. Both of these are okay, but we're going to want to write it as simple as possible. All right, let's take a peek down here. Same thing, we're sharing that times 2 with what's on the inside. So we have 2 times -3, so -6. And then our x squared, it stays exactly as it is, just x squared. We're going to keep that symbol in the middle and continue to share. So -2 times 3 is, or not -2, 2 times 3 is 6, and we keep that x. Okay, nothing else for us to do here. That's where we're going to stop. All right, our next one, we're multiplying by -2. All right, so negative 2 times negative 4, two negatives make a positive, so that's positive 8x. All right, we're going to keep this symbol in the middle. And now we're done with it. So we've got negative 2 times 3, which gives us negative 6. All right, what do we know? Two negatives make a positive. So that gives us 8x plus 6. And that would be our final answer for that one. So again, just adding on to those building blocks as we move forward through this unit.